Here's another application problem that asks us to find a maximum. In this example, it says that a daycare center has 32 foot of dividers with which to enclose a rectangular play space in the corner of a large room. The sides against the wall require no partition. Suppose the play space is x feet long. Give the answer the following questions. The first question is give the function that represents the area of the play space. To do this, I'm first going to make a drawing. Let's say that I make these the existing walls. Then we have 32 foot of dividers. So what I will do, it says on this one, it says suppose the play space is x foot long. So I'm going to create a length. And it says let that length be x. If we had 32 foot of dividers, and I have now used x foot of dividers, then the amount that I have to create the other length is 32 minus x. You can think of it as if you knew that x was 10 foot, then to make the other side, you knew you would have 32 minus 10 feet left over. And so now we have a drawing that corresponds with our question. This part asking for give a function that represents the area, because this is a rectangle, then we know that area is length times width. On this one, the way I'm going to write my function is capital A of x equals my length is x times my width is 32 minus x. So we have the product of our length times our width being our area function. I've called my function capital A for area, and I've used function notation saying of x, indicating that x is the variable in my function. What is the domain of this function? Well, the domain is going to be x values. In this case, we see that our x value represents a length. Well, we know that because it's length, it must be greater than 0. In other words, we can't have a length measuring 0, so it can't be 0, and it must be values larger than 0. We also know that because we only have 32 foot of dividers, that the most the length could possibly be would be 32. However, if it were actually 32, then we wouldn't have anything left for the width. And so on this one, I would write my domain as the set of all x values such that x is between 0 and 32, not including either one of those. And the last question is what are the dimensions that would enclose a maximum amount of area? So on there, they're wanting to know what is the length and what is the width. To do this, I will first graph the function that I have written for the area. So I will do y1 equals x times 32 minus x on my calculator. If you have a function in there, clear that function out, and then we can do x times 32 minus x, close friends. And then for this one, as far as graphing, we want to think about what a window would need to be. Well, we already have one part of our window, and that is from part B, we were asked to determine the domain. So for the domain, the x minimum would be 0, the x maximum would be 32. The range of this function is the actual area. And so on here, we're going to have a little bit of a hard time determining the range, but we can use an idea that we understand, and then we can basically play with what the high number would need to be. We know that area must be positive, so we would know that it has to be bigger than 0, so we're going to let the y minimum be 0. Now, with the other number, we know it's going to be something relatively large. In other words, on this one, we have that the total amount of, we're going to say dividers was 32, and so if we're finding an area with that, it's going to be a relatively large number. So let's say that we make our maximum go to 100. Now, if the 100 is too large, we can always make it smaller. If it's too small, then we can always make it larger. So we can kind of play with that maximum y value until we get something that's right. So let's go and set our window on our calculator. So we go at 0 to 32, and then 0. Our guess for the top number is 100. And then we can graph. We can see on this one that our top number is not large enough on our y-axis because our graph goes off of our calculator. So on this one, go to Window, and let's bump that value up. Let's make that value maybe 300. So I'm going to come down here and I'm going to edit this, and let's say that we make it 300 instead. And that's just a value you're going to have to play with. So now go to your graph, and we see that bumping it up to 300 makes it large enough for that graph to be shown. We have our maximum value up here at the top. So on here, I actually want to find the maximum. So in other words, I want to find this ordered pair. So I'm going to do second, trace. I'm going to go option number 4 since that's maximum. I've warned you in a prior video that sometimes it will actually take you to the actual answer, but that I would go ahead and work it. So on this one, go to a little bit to the left, fall off that flat part at the top, go a little bit to the right. Make sure to go over and past that flat part, press enter, and then when it asks for a guess, press enter again. And so on this one, it says that we have a maximum of 256 at x equals, and we're going to round that to 16. All right, now from here, we're able to answer their question. Okay, I'm going to minimize my calculator so we can see what we're looking for. It wanted to know what dimensions is going to maximize the area. And so on here, the x value that I found would be the original length of my play space. And so on here, for dimensions, we would know that the length would be 16, and then I want to look for the units that were used in this function. We see feet were used, so it's going to be 16 feet. And then the width was 32 minus x, so it would be 32 minus 16, which in this case would be 16 as well. And so the dimensions would need to be 16 feet by 16 feet to maximize the area of that play space.